See, native Ghidra layer Android.
Hi everyone, thanks for watching laurieWIRED. And in a previous video, we looked at how we could take a Java method and translate that functionality over to native code. So in this video, we're going to take that built APK or Android package and see what it looks like from the reverse engineering standpoint. So we're going to take that bundled APK and extract all of the libraries from it and throw that into Ghidra, and then analyze that native C++ code and see what that looks like. And we're also going to go through and try to apply the proper types to the parameters and variables in there. So let's open up our previous application. So this was our main class in Java, and this used system.load library to load a native library named translateNative method. And this declared two native methods inside of that library, this stringFromJNI, which was auto-generated by Android Studio when you make a native application. And we also wrote this callRetString native, and we called that just to set the text inside of the application. That was declared inside of our native library with this function name right here, which was the fully qualified class name, and then the actual method name that we wanted. And that contains our functionality to actually call this retString method, which was declared in Java. So that was our background right here. So let's jump into what does this look like when it's actually compiled. First of all, I have my built application right here. So let's just see what it looks like if I throw it into JDEX. It should look pretty close to the original code that we have, since I didn't do any kinds of obfuscation. So this is almost the original source code that we wrote together. So let's give that a second to load. So here we have our main activity was this translate native method right here. And this looks pretty much almost exactly the same as what it did in Android Studio, just the stuff is moved around a little bit. So we have our native declarations up top here in our instance variables, and then our Java definitions over here. So if you take a look, see right here, it looks pretty similar. So the main thing that we notice here is that we have public native string. So this means that this method and this method are going to be defined in C++, and it's looking for a library called translateNative method. So if you're using this system.load library, it's looking for the library inside of the default system lib folder. So if we go over to resources, we check lib, we see all the different instruction set architectures that this particular application supports and will run properly on. So we have a 64-bit, 32-bit version of ARM, a 32-bit, and a 64-bit version of x86 as well. And if we open these, we can see this lib translateNative method.so. So if we drop the lib and the .so, this library name should match this name right here. Now you may be saying, when we developed this over in Android Studio, this was called nativelib.cpp, but when we loaded it inside of our main activity, we did actually, where did we load it? Oh, it was right here. We did actually load it with this proper name, but if you look at the CMake file, you can actually see why it's called something different. So this is saying, in our project folder, it's called nativelib.cpp, which, yes, it is right here. But the actual name of the built native binary is going to be translateNative method. So that's going to be lib translateMethod.so. So let's see, how do we actually get this native binary, since I can see it right here, but I can't actually analyze this inside of JDEX. So all we need to do is come over to our APK. I'm going to right click, and I'm going to use 7-zip to extract all of the contents, since an Android application or an APK file is just a special kind of zip file. So let me just extract this to this partial native folder. Double click here, and we see our lib folder and all of our Dalvik executables. So that contains our actual executable code. So I'm going to go over to lib, and let me just pick 32-bit version of ARM. So here is our actual native binary, this .so file right here. So this is going to contain those method declarations that we wrote over here in our C++ library right here. So if we want to actually analyze this, we have to open this up in Ghidra so we can look at the underlying ARM assembly, which is going to be a 32-bit version of ARM right here. Let me open up Ghidra. Okay, and we have a project right here, or you can create a new project. And I'm just going to drag and drop right there. So if you're wondering what this liblog.so is, it's probably just auto-generated by Android Studio for logging purposes. But this is the one that we actually added our own user code to. So we've loaded our selected binary. So let's let that load into Ghidra. Okay. And then we can just double click to actually analyze and disassemble and decompile the code in this. Yes, we would like to analyze. I'm going to also select this so we can decompile more. And we'll let it load for a second. All right, I think that looks good. So this is what you're going to see when you actually open up the binary inside of Ghidra. These are all the bytes that comprise the actual file. So you see we have our header right here. So if we looked these up in ASCII, these 45, 4C, 46, that's going to spell elf. And so if you wanted to see an example, just open this up in Notepad++, you see those bytes match right there. So what we are interested in is actually taking a look at those methods that we wrote ourselves. So I'm going to come over to my functions table right here. And we see JavaCom example. Why doesn't that want to stay open? JavaCom example, translated method, main activity, which was, if you remember, where's my Android Studio? Beginning of both of our user-defined methods. So that was the fully qualified class name, so the package name plus the class name. So if we go in here, we should be able to see two methods. Let me expand this. So we have our callRetString native, and we also have our string from JNI defined over here. So we have stringFromJNI and callRetString. So what I'm going to do is I'm just going to show you how we can apply the proper types and make this native binary look just like our Android defined source code right here. So let's first look at the one we wrote together, not the auto-generated string from JNI. So let me give us a little bit more space here. And if at all possible, I like to look at the decompilation, although sometimes you'll be forced to look at the assembly output. So if you're not sure, watch my series on how to write assembly and you'll feel very comfortable analyzing this as well. But let me just push this over here. So this is what we're going to see generally when we open up a compiled native Android binary inside of Ghidra. So if you notice, it did correctly type this as the Java native interface, or this is a pointer to that structure that contains all of the methods inside of the JNI. But if you're looking over here, it incorrectly typed our second parameter as a JMethodID, and this happens honestly pretty often. So what you can do is you can actually use some of the Java code to help you properly type the corresponding native code. So what I mean by that is if I come over here and I look at my declaration, we have this callRetString native right here that takes one integer as a parameter. But the thing to note, if you're working in Android code, the first parameter is always going to be that pointer to the Java native interface. And then the second parameter is going to be a pointer or the current object that this method has been called on. So we named this obj right here, which is of type JObject or Java object. And then we have our actual JInt parameter. So if you didn't have the source code and you weren't sure of these conventions, this might get really confusing. So let's go through and add these proper types and make this look like it makes more sense. So the first one, I'll leave that here. That's perfectly fine. The second one, this JMethodID, I'm actually going to change the type right here. And I have included this library that contains all of the different symbol data for the Java native interface. And I have a previous video on it, but all you need to do is just download this GDT file, and I'll include a link for this in the comment section of this video. And you can just do this down here, and then you'll just need to do open file archive, and then just select that GDT file, so no issue there. But once you've done that, you should have all of the different JNI symbols available for you to type different objects. So let's just right click here, and we're going to do retype variable, or you can do Control L if you prefer, and let's see what type this was expecting. So remember, that second parameter is going to be of type JObject. So let's start typing JObject, and you can see that's inside of our JNI library. So we can just click on that, select OK, and so now that's going to be the proper type right there. So for our third parameter, this is just showing up as undefined because it's not sure what kind of type this is. But if you remember, if we go to our Android Studio, this was of type JInt, which also shows up in JDEX when you declare this method as type int. So that's an easier one to note because that one actually appears inside of JDEX. So let's go through here. We'll retype this variable as well. So I'm going to do JInt. And it wasn't a pointer, it was just the actual object itself. Right? Yes. Okay, nice. So now we actually have the proper types for each of our parameters, so that's good. This is looking a lot more like the actual source code right here. And I'm going to rename each of these parameters right now, since you see these are named param1, param2, param3, not very helpful. If you're wondering how I highlighted all of these, you can press the middle scroll button on your mouse, just by the way. But I'm going to do rename variable, or you can hit L to rename this. And I'm going to call this key-env, so a pointer to the JNI. So that's going to rename all of that right there. So looking better already. And then if I go over here and I rename this param2, let's do rename. I'm going to call this obj again. So this is going to match our definition in native code in Android Studio again. So there we go. That's fixed everywhere. And now our three, let me just match whatever variable name I put here so it makes sense. Num to print. So if you didn't have the source code, you wouldn't know that this was supposed to be called num to print, but I do know that. So you could call this whatever you wanted, but I'm just going to rename this. And my usual naming convention is MW for malware. Then I'll just do the actual variable name, num to print. So there we go. Nice. Okay, so let's move on. Now our parameters look good. So our method definition looks proper. The signature of it right here. Let's look at the variables we have now. So this is a J class. So this is a pointer to a J class. And if you remember, this is exactly what we would expect. since we have our retString class right here. And this is putting the value returned from this find class method from the Java native interface and storing that inside of a J class object. So if we look at this find class, we know this returns a pointer to a J class, but this has already been properly typed right here, so there's no need to fix that. I'm just going to rename the variable. I'm going to call this var. And let's call this J, what class was it? It was this main activity class that was the plain text string. So main activity pointer. Okay, so that looks good. This is already looking pretty easy to read, honestly, pretty close to the source code. And then nextly, we have this uvar1, and this has not been properly typed. So if we want to type this properly, I know this is going to return a type J method ID or Java method ID, but if you wanted to see what this JNI function returned, all we need to do is copy right here. So get method ID, and we'll just pull up our JNI Function Reference. So I've already got it right here. So these are our JNI Functions. JNI Functions right here. And then I'll do just Control F and do get method ID. So you can see this is returning a type J method ID. So let's pull that up and fix that in Ghidra. So again, we'll do retype variable, and I'm going to do J method ID. And there we go. So now that's the proper type, and you can see it's typecasting this to J method ID. So let me also rename this variable. We'll do var, and then what method ID is it looking at? This is looking at the retString method right there. So we'll do var retString method. Nice. Okay, and I think that's honestly looking pretty good. I don't think we have any more variables to cast. So we have our find class, which of course is nice. It's getting our plain text string of which class we're trying to find, which was this main activity class that we defined over here. And we have our J method ID, which is the particular method that we're trying to call, and storing that into this variable. And then we're taking the current object that this method has been called on, so this object right here, taking this retString method, which is the method ID we want to call, taking the parameter that's going to be passed to this retString method, and we're actually calling that retString method even though it's defined inside of Java. So if we open up JDEX, we can see our retString method is actually defined right here, and that is what this native method is going to be calling. So I think that one looks good now. This looks almost exactly like our original source code. If we go here, I would say that's pretty close. Yeah, looks good. Okay, so just one more example. I want to go over and also fix our, what was the method? stringFromJNI method. So we didn't actually define this. This is just auto-generated when you create a native method inside of Android Studio. So I just kind of want to clean this up real quick, just to show you a few more examples. So again, here is the actual assembly code for this particular method, but looks like decompilation was successful, so let's take a look at that. Okay, so actually I think there's one thing we missed here, is the return value, since we're actually expecting this to return a string. So we can try and fix that too. So that's not returning void, that's actually going to be returning jstring. So right here. So we can click on that. So now we have the return value fixed as well, since if you look at the Java code, you can tell this is returning a string. So in Java, this would be a type Java string or JString. It's just a side note there. Now I think we're all good. So first of all, let's go through and fix our stringFromJNI method too. We can do the same thing because we know this is also returning a string. So retype return, it's going to be jstring. Nice, looks good, since this is also returning a string right here. So we also have our JNI env, which looks like it was properly labeled. So let me rename this to pointer to the environment or the Java native interface. Now, one thing I've noticed when Ghidra is decompiling Android native methods is that if this object is not actually called, it doesn't put it in the actual method signature when it decompiles it, since nothing is ever referencing it. So if you notice there's a method that doesn't have it, don't be confused. Sometimes that happens and sometimes it doesn't, so just kind of play it by ear and figure it out per situation. So I think our declaration looks good. We have our return value. And let's see, we have char, which if we look at the new string from UTF, that's one of our JNI methods. We can see because JNI and then calling the particular JNI method. So we can just look at our reference right here. So this is returning a jstring, and it's taking this char array or a pointer to an array of characters right here, which is going to be the bytes. So let's see, did we type that properly? Yep, char star, looks good. So this is going to be, let me rename this, var, let's call this string 1, since I'm pretending like I don't know what this is doing if I was looking at this for the first time, even though I know this is putting the constant hello from C++ in there. Okay, let's see. We can ignore this stack check guard all right here, since this is just related to checking for a buffer overflow. So just, if you don't know what that is, don't worry about it. Just ignore it for now. So ignore that. I think that looks good. Let's see, we have our jstring. Oh, that was properly typed right there. That's kind of nice. So we'll rename that. So this is basically just taking in this char star, which is of type C++ string, and then it's returning a Java string to that. So let's say this is going to be var string 1, but in Java. So that looks good. This looks good. This was just declaring our string in C++, so I'm not going to worry about all of this going down the rabbit trail for the method call. This is just a lot of compiler optimizations. But we have our C++ string right here. So let me actually rename that for clarity. New string 1, let's call it CPP for C++. And then we have our var string 1 for Java. If we look at that, that's the actual return value, and this is indeed returning a JString variable. So that looks good. We can ignore this because this is again just checking for buffer overflow, and that's just a compiler optimization. So I think that looks pretty good. Basically, the thing to remember is look for the usage of your JNI methods and try to filter out anything that looks more like a compiler optimization, so you can find the actual meat of the code, which is going to be anything using the Java native interface environment pointer right here. So thanks so much for watching laurieWIRED, everyone. In this video, we took the APK where we had a partially native implementation of some of our code, and we threw that native binary into Ghidra and saw how we could fix all of the corresponding types and include the JNI symbol information into our code and actually make that look almost exactly like the original source code. So thanks so much for watching laurieWIRED, and I'll catch you in the next video. Lots of... Oh my gosh, too fast. Okay, let's try this again. Okay.